Hello, this video is going to show how we can measure structural coverage on a multi-threaded Wi-Fi enabled application. Connected to my laptop at the moment, I have this Launchpad from Texas Instruments. And when I execute the program, I'm going to be able to connect to the Wi-Fi and actually connect to this simple link. Once I'm connected, I'm then going to be able to open a web page and actually control the execution from this web page. Well, let's take a closer look at this. Now, this is Code Composer Studio, and inside here I have an application that's provided with this Launchpad, and it's composed of 3 libraries, and they get built into this executable. So the first library is the driver library. The second one is the OS library, so using FreeRTOS, and then the third library here is controlling the Wi-Fi, the simple link. So I've already built those libraries. Let's now check we can build the executable. So let's do a rebuild here, and that's now using the GCC compiler, and we should be able to see that it's generated this output file, and we can see it's linked in the other libraries. So what I'd like to be able to do is I'd like to be able to execute this, and as it executes I want to be able to see, well, how much of this code have we actually exercised. So let's go and take a look at the code. So this is TBvision, and inside TBvision I've already analyzed the program, and we can see we have a number of files here. Well, let's take a look first of all and look at maybe a system call graph. So the system call graph is going to show us how all these functions are interconnected. If I wanted, we can see very clearly in different colors. We have some function pointers, we have some external functions, we probably have some system calls. Well, let's take a look and maybe look at some metrics on the code. Let's look at the metrics that give us an idea of maintainability. And in this particular case, let's sort and find the most complex function. In this case, we're looking at the cyclomatic complexity, and it looks like I must have set a threshold at 10. And anything with a value above 10 is being shown here in red. Well, let's take a look at this simple link HTTP server callback. Let's take a look at a flow graph. And the flow graph is going to give us a graphical representation of that code. So what's this block here? Well, let's click on it, and it's going to show us that corresponds to this block inside the code. What about this block here? Well, that corresponds to this one. Okay, so let's go and execute this code and find out how many of these paths have we actually exercised. So let's close this down, and what we're going to do is we're going to perform the dynamic analysis. I've already generated the instrumented program. I then want to build that instrumented program, execute it, and finally get the coverage. Now the problem is the program never ends, so what I've done is I said, well, when we disconnect from the device, that's going to execute this particular function. At that point, I then want to read the data from the target. So let's start this. So this is now starting to build the instrumented program. Then it's going to connect to the debugger on the target and download it. So there we can see we're connected. We're now executing on the target, and I should now be able to connect to the Wi-Fi. So there we have my simple link. Let's connect to this. And now let's go to the web page that's being published, and there we can see we have a web page that's published. If I lift the board up, we can see it actually detects that. If I wanted, we can actually go to this view. If I open the door, nothing happens. If I switch this on, then open the door by lifting the board, we can see we've detected it. Alright, let's close that down, and now let's disconnect from the device. And when we disconnect, we can see we're now uploading the results from the target. So once it's done that, it's then going to analyze those results, and we're going to be able to find out, well, how much of this code have we actually exercised. So once again, let's go to the system call graph, and the system call graph this time, let's put it into view where we can see the coverage. And once again, we can sort, and we can see there's a lot of functions here that we've got no coverage at all. So it's possible a lot of this is dead code. Alternatively, maybe we haven't exercised the code enough. Well, where have we got coverage? Okay, we've got 100% coverage for these functions, but some of these we haven't got 100%. Here's the one we looked at earlier. So the simple link HTTP server callback, we got 72% statement coverage, 55% branch decision coverage. Once again, let's take a look at the flow graph. And on the flow graph, we can see very clearly which parts of the code have we executed in green and which parts have we not executed in red. And if we take a closer look, we can see there's quite a few places where we haven't executed the code. Okay, so hopefully that's given you a quick overview of how we can measure structural coverage on a multi-threaded Wi-Fi enabled application. And if you'd like more information, then please don't hesitate to contact us at LDRay. Thank you.